Let's jump right to the chase. Here are the reasons why Minecraft doesn't have infinite render distance. And here are a few of the reasons that aren't actually preventing infinite render distance. Howdy, my name is James. I'm a professional software developer and the creator of Distant Horizons, a Minecraft mod that allows massive render distances without harming performance. And with the help of several other Minecraft modders, we've put together this comprehensive list of all the roadblocks and pitfalls that prevent Minecraft from having a render distance similar to like what you'd see in Skyrim. To start, what's preventing us just from going into Minecraft right now and dragging the render distance slider all the way past 32? The first problem is rendering complexity, aka the amount of work we're asking our computer to do when drawing a scene. As we increase the render distance, the number of chunks we need to render increases much faster than you might expect. At a render distance of 2, we need to load and render 25 chunks. At a render distance of 4, we need to load 81 chunks. At 8, we need 289 chunks, and at the max distance of 32, we need a staggering 4,225 chunks. Here's a graph showing off what I mean. As you can see, the number of chunks needed for a given render distance goes up faster the further we crank the render distance. That's bad. This means that no matter how fast we make our renderer or how VRAM efficient it is, we'll always run into the ceiling due to the quadratic growth of the number of chunks we'll need. But rendering is only half the problem. If you click this little button right here, we open a whole other can of worms. When you connect Minecraft to a server, your client will have to download all the chunks before they can be rendered. And then, once they've all been downloaded, the server will have to keep track of all those chunks so they can be updated when things change. Think players breaking blocks, redstone firing, or sheep eating grass. With how Minecraft is currently designed, all these chunks must be actively loaded for you to see them. And as the number of chunks each player needs to have rendered increases, that quickly increases the load beyond what the server can handle. Okay, so we can't just drag the render distance slider up. Is there something else we can do? Well, if the problem is that we have too many chunks to keep track of, the simplest solution is to stop using chunks. Instead, we want to use something that's less detailed while also covering a much larger area. This is where LODs come in. LODs, or levels of detail, are a rendering technique used by games like Skyrim or Minecraft mods like Voxy and Distant Horizons to simplify the geometry of distant terrain in order to make it easier to handle. Or, in other words, don't spend much time drawing far away things that you can barely see anyway. Although how this is done varies wildly. Looking at Voxy, Farplane 2, and Distant Horizons, we can see 3 very different but perfectly valid methods of simplifying distant terrain. Voxy renders distant terrain with increasingly large cubes, Farplane 2 smooths out distant terrain, and Distant Horizons merges blocks both vertically and horizontally. However, LODs aren't a silver bullet, and they contain several roadblocks and gotchas that you may not expect. So, let's take a closer look. To start, let's go over the easiest problems and slowly work our way into the more difficult ones. LODs in Minecraft have been added by multiple mods, each using their own approach. This means that many of the technical roadblocks have either been completely, or at least partially, solved. So let's take a closer look at these technical problems first. The most visually interesting problem is rendering, aka drawing stuff on your screen. For now, we're going to skip all the complications and costs related to building a new renderer, and just talk about integrating one into Minecraft. Minecraft's current renderer is what's called a single-pass renderer, which means everything is drawn to the same canvas before being put on your screen. This is the method used by Nvidia, or if we were just to increase the render distance past 32. This works well for Minecraft since there aren't any complicated shader effects like reflections or shadows. However, it does cause some potential issues if you want to see really far. Computers don't like the concept of infinity. You need to give them hard boundaries. When you set up a renderer, you need to tell the computer, I want to see everything between this distance and that distance. And the bigger that distance is, the more likely you'll run into something called Z-fighting. Z-fighting is a rendering limitation where the computer doesn't know what object is supposed to be in front of another, which either looks like a weird stripy pattern or objects appearing behind things that they should be in front of. For example, here are some waterlogged leaves. If everything is working as intended, the water should be behind the leaves. But if we have Z-fighting, they'll look like this, where sometimes the water is in front and sometimes the leaves are in front. Which you can reproduce in vanilla Minecraft right now. Just put down some leaves, crank your render distance to 32, and grab a spyglass. This is a problem. The fact that we can already see Z-fighting with the relatively low render distance Minecraft already has means cranking it up higher isn't an option. The issue will only become worse the further out we go.
But luckily there is a solution. Reversed Z is the method utilized by Farplane 2 that changes how the computer tracks distance and allows for significantly increased render distances with a much lower chance of Z fighting. The only real drawbacks with reversed Z are the less common format requiring some code changes since most libraries and people aren't used to it.
Otherwise, if we don't want to touch the rest of Minecraft's renderer, we could use something called multipass rendering. In this style of rendering, different parts of the screen are drawn to different canvases before all being merged together at the end and then put on your screen. This is how mods like Voxy or Distant Horizons handle extreme render distances, and games like TF2 or Counter-Strike handle their skyboxes. By splitting up our near and far rendering passes, we can see much farther without having to worry about Z fighting, since we can give the computer two entirely separate, much nicer distances to work with. But this improved quality in the distance comes at the cost of nearby quality, specifically the border between the near and far rendering passes. Since each rendering pass is an entirely separate piece, they can't talk with each other to determine where one starts and one ends. This is less of an issue for games like Minecraft since it doesn't have reflections or other complicated shaders. However, it does still occur when looking at large transparent areas, like an ocean. Luckily, there are several ways to deal with this overdraw issue, where objects are rendered twice on top of each other. Distant Horizons fixes this by fading between the near and far rendering passes. This isn't a perfect solution, since the fade region is a little bit darker than the surrounding area, but it looks good enough. Voxy, on the other hand, tracks what chunk sections have already been rendered by the near pass, and then skips them in the far pass, which can provide near-perfect seams, provided the near and far pass line up correctly. So now that we have a renderer that can draw things really far away, we need something to draw, which means we need to talk about world generation and the very first problem we discussed in this video, chunk count. Let's say we have a modest render distance of 256 chunks, which is just shy of how far the horizon is in real life when viewed at 2 blocks or meters above sea level. Also, quick note, this is just to see the horizon. If there's a mountain in the distance, you'll be able to see it from much farther away than 4 kilometers. To fill in that render distance, we'll need 263,169 chunks. That's a lot. It doesn't matter how fast your generator is. 263,169 chunks is just a lot of chunks. And this problem gets only more pronounced as the render distance increases. If we wanted to see all the way to the real-world horizon while at the default overworld build height, 257 meters above sea level, we'd need a render distance of well over 3,500 and a total chunk count of over 51 million. So, how do we deal with this? Well, the obvious solution is that we just need to make the world generator finish instantly. However, since I'm not a wizard, and neither are the fine people at Mojang, at least as far as I'm aware, that's unlikely to happen. So what are our realistic options? The first is multi-threading. Multi-threading allows your computer to work on multiple jobs at the same time, allowing for anywhere from a 2x to 32x speed improvement, depending on how big your CPU is. However, as powerful as multi-threading is, it does have a few drawbacks. It's really difficult to do right, and it doesn't help low-end systems very much. If multi-threading is done poorly, it can cause world gen to look wrong, cause weird out-of-order issues where suddenly talk like Yoda your problems will, or it can cause deadlocks where your computer gets stuck and congratulations, now nothing is getting done. And even if multi-threading is done perfectly, it only helps computers that have a high number of cores that aren't actively being used by other tasks. If you're on a low-end computer that only has a few cores or is already overloaded running other programs, multi-threading won't provide much, if any, benefit. But, all that being said, if we do have a high-end CPU that has cores to spare and our code is designed well, multi-threading is a powerful tool that can cut our world gen time down significantly. So that's it? Just utilize more of your computer? Not quite. There's another world gen change that's even more potent than turning your computer into a space heater: variable or end size generation. Remember back when I said LODs render distant terrain using less detail than what's nearby? Because of that, we can actually generate distant terrain at a much lower detail the further it is away. The term end-sized means generating only some of the relevant block columns in a given area, instead of all of them, then pretending that the columns you didn't generate are the same as the ones you did. For example, if we only need to generate a single column for a chunk, instead of generating all 64 block columns in that chunk, we could just generate one column instead. Let's look at some real-world numbers using Distant Horizons as a baseline. Looking back at our 256 render distance example from earlier, that render distance covers a little over 250,000 chunks. But at the default quality preset Distant Horizons uses, we only need to render about 430 LODs. With end-size generation, Instead of generating over 250,000 chunks, we only need to generate about 430 LODs, which is a significant improvement. And this generator only becomes more impressive as you increase the render distance. Since we can render distant terrain at lower and lower resolutions the farther away it is, that means you can generate even lower detail areas, which cover even larger areas. So, while the number of chunks needed to generate that area may increase quadratically, the number of n-size generation requests you need increases at a much lower rate. In fact, this sort of generation can go so much faster that mods like Farplane 2 or Big Globe can use it to generate terrain all the way to the world border in a matter of seconds. That's approximately 14 trillion chunks worth of terrain in seconds. But there are a few gotchas. Minecraft's world generator isn't designed with this generation mode in mind. To do this properly, a lot of Minecraft's current world generator would need to be revamped, changed, or even skipped. For example, both Farplane 2 and Big Globe only create the world's surface. They skip features like trees and structures like villages, which may not seem like a big deal, but causes the world to look quite empty when missing. But just to keep this conversation moving, let's say we've solved all those problems and we now have an extremely fast world generator that can provide world data quickly into the distance. Now we need to put that data somewhere. Anyone who's pre-generated a large server world knows that Minecraft worlds can get big, like hundreds of gigabytes big. And adding LODs to that mix only increases that size. But why do we need to store that LOD data at all? Why not just generate everything from scratch each time we load into the world? If your world generator is fast enough and nothing was modified, that is a possibility, and is what Big Globe does with their LOD generator. However, as soon as you modify the terrain or build a giant castle, you'll need to save those changes, otherwise your super cool build won't be visible from far away. And this also assumes we have an impassably fast world generator that can instantly get whatever we need. And since we don't currently have a perfect hyperspeed generator, it's much faster to generate the terrain and then store it, so we can quickly pull it from your hard drive and then put it on the screen. This is the same reason Minecraft uses chunks stored to your disk, even if they weren't modified. So with all that, you may be asking, what's the solution? And sorry to break it to you, but there isn't a solution, or at least not a clean one. Don't get me wrong, there are some tricks we can do to reduce the file size of the LOD data we're dealing with, whether that being specialized compression and advanced bit packing, or just storing less data a la n-size generation. But in the end, we still have to store something, and the further you want to see, the more data you'll have to store. But with that, we've covered all the technical problems. We have a renderer that can draw terrain way off into the distance, we have a world generator that can run fast enough to feed our renderer, and we have somewhere to put all this terrain data. I bought another hard drive. And with that covered, now we have to get to the less fun but more influential roadblocks. As I said previously, there are already mods that add extreme render distances to Minecraft. The technical limitations aren't what's holding us back. The real showstoppers that keep Minecraft from having infinite render distance are opportunity cost, the mythical man month, Minecraft's design, and demand. Let's start with opportunity cost. Opportunity cost is a big fancy leadership phrase that means what are you trading off when you pick one decision over another. For example, when playing Minecraft, if you decide to spend an hour mining for diamonds, you can't spend that same hour building your farms. Usually software development is most limited by opportunity cost. If you spend a week working on a new feature, that means you aren't spending that week fixing issues your user base has been emailing you about. But how much of a cost would it be to add LODs to Minecraft? While I can't speak for Mojang, I can speak for myself. To bring Distant Horizons from proof of concept to beta, it took me about 3,920 hours over the course of 4 years. Please note that this number is a lowball estimate. I never expected Distant Horizons to get this far when I started, so I wasn't tracking my hours. So let's put that number into context. A full-time job in the USA, ignoring time off, is 2,080 hours a year. So in other words, it took me roughly 2 years of full-time work to bring Distant Horizons to a somewhat functional state. But here's the kicker. While I was the main contributor to Distant Horizons, that hour count was just for me. Over the last 4 years, 21 other people have helped along the way. How does that impact our time cost? That's an excellent question, and I have no idea. Unfortunately, I don't have an hour count for anyone except myself. But this does highlight a different part of the problem. Building an LOD system isn't simple. It needs a team. You can't just give this job to a single person and hope it'll work out, unless they're just that good. This means that you won't be locking down one person's time, but likely several, if you want to add a feature of this complexity to Minecraft. And as a reminder, all that time was just for a buggy mod. Even though I'm sure the Mojang devs are significantly better at their job than me and could have built all of this in half the time, they also have to hit a much higher level of polish before their work can be added to the game. So, to put this another way, if we combine an incredibly complicated feature that has a high time cost with needing multiple people, we end up with the possibility that Minecraft won't get any big updates for a while, which is a roadblock all its own, which we'll cover more later. Now, just for fun, let's take a little math sidetrack. I showed the hour cost for Distant Horizons, but what would the dollar cost be? Now wait. Before you make those respectful, well-meaning comments saying, but Mojang is owned by Microsoft, don't they have infinite money? As we covered, and as I will go into in more detail in a couple minutes, money isn't the limiting factor, it's time. This little tangent just provides some additional context, and because big numbers are fun. At the low end of our cost analysis, let's assume an hourly wage of $7.25 an hour, the minimum US federal wage. Multiplying that by $39.20, we get a total cost of $28,420. Not too bad. That's roughly the cost of a 2025 Ford Escape. But most software devs work for a lot more than $7.25 an hour. I know I do. So let's try that again using my salary. I make about $32.55 per hour. Multiplying that by $39.20, we get a total cost of $127,569. Okay, that's a little bit more expensive. That's closer to 5 Ford Escapes. But that's not even the high estimate. I work as a software contractor. Our hourly rate for clients is quite a bit higher than my salary. Now, I won't give the exact hourly cost, but I can say it's generally around $200 an hour. And plugging that number into our equation from before gives us the staggering total of $784,000, the cost of 28 Ford Escapes or one Robinson R-44 helicopter. Now, am I saying that adding LODs to Minecraft would cost Mojang the equivalent of a fleet of SUVs? No. I can't say exactly what Mojang's cost would be, and to be frank, I doubt y'all would care. Big corporation a la Microsoft and all that. This is just to put some context to how big a project increasing Minecraft's render distance would be. But with those costs in mind, if money were no object, then what is stopping Mojang from just throwing a bunch of Ford Escapes at the problem? In software development, there's a well-documented rule known as Brooks' Law, or more entertainingly, the Mythical Man Month, both of which boil down to the same idea. Adding more people to a project means your project will take longer to finish. But why is that? Many hands make light work, right? Well, software development isn't like painting a house or digging a hole. It isn't always obvious what the next step is, and each person needs to be careful not to step on anyone else's toes. Here's an analogy to help explain the problem. Let's say we're making a feast for a big party. We have a private kitchen and a team of chefs. In that kitchen, there are a limited number of ovens, sinks, and countertops. You can't just keep adding chefs and expect the food to be made faster. At a certain point, you'll run out of dishes the chefs can work on and counters they can work at. And this also assumes that each chef knows exactly what they need to be doing. When bringing on a new team member, they know nothing, or at least very little. You'll need to have an existing team member stop what they're already doing to bring this person up to speed and help them learn. That means you've effectively made the process slower until that new person is familiar enough with your workflow that they can work on their own. Leaving our analogy, adding new people also assumes Mojang as a team even wants to grow in the first place. They may already be very happy with who they're working with and don't want that dynamic to change. All that to say, even with an unlimited budget, you can't just keep throwing people at the problem to make it go away. Unless there's a strong reason, you'll likely be limited by the number of team members you already have, which means carefully balancing what each person on the team does with their time, a problem that no amount of money can fix. But again, for the sake of argument, let's assume all of those problems have been solved. We have a group of developers who know Minecraft's codebase and are all ready to work. The next step is making sure that this extreme render distance would even work with Minecraft. Now, that statement might seem a little odd, but let me explain. Whenever you add a new feature to your game, you need to make sure it meshes with everything around it. If you've played enough modded Minecraft, especially around the 1.7.10 days, you probably know what I mean. Some mods add features that don't mesh well with the core game, breaking that vanilla feel. Maybe their art style doesn't match so they stick out, or maybe what they do just feels out of place. Here's an analogy of what I'm talking about. This is a screenshot from the Feed the Beast mod pack, and looking at this screenshot, you can instantly tell it isn't vanilla. The armor is too high resolution and the machine blocks in the background are too simplistic, just to point out a few simple things. So, do extreme render distances mesh well with how Minecraft is currently designed? Yes, but also no. I wouldn't have spent over 4 years of my life adding LODs if I didn't think Minecraft would be better with them, but I also recognize that this change may not slot in perfectly with the wider game as a whole. So why is that? When designing a game, you need to know what scale you're aiming for. That scale will affect everything from how you traverse the world to how it looks. For games like Space Engineers, where the render distance is far enough that you can see multiple planets at once, you need to have a transportation option that allows you to quickly travel between those planets. And Elytra won't provide nearly enough mobility if you suddenly want to travel between Earth and the Moon. You can already see some of these issues if you use large render distances with a mod like Voxy or Distant Horizons. Once you can see across multiple leagues of ocean, you might come to realize that your little boat isn't nearly fast enough anymore. But transportation is only part of the problem. Minecraft's world gen is designed for a render distance of somewhere between 8 and 16 chunks. If you suddenly increase that render distance to 256, 512, or higher, you may find that it doesn't look quite right anymore. Suddenly, oceans feel like small lakes and mountains like little hills. If you change this world generation to fit this new visibility, that would change the game's feel quite a bit. Speaking of feel, this next item is a little subjective but still needs mentioning. Art style. When changing a game's render distance, you change how the game looks and feels. And that also assumes that the distant terrain all looks perfect, which, I hate to break it to you, it won't always be. If you play Minecraft right now, you'll likely be used to all of your builds being perfectly crisp with all the small details visible, regardless of distance or graphics settings. But for LODs to work, they, by definition, need to render at a lower resolution or quality. And depending on how that drop in quality happens, it may be quite jarring. In Distant Horizons, this often appears most noticeably on pixel art or modern-style skyscrapers. As the quality drops, there's less geometry that can be used to represent the build, so it starts to merge or skip blocks, causing some unfortunate side effects. Whereas in Voxy, quality decreases can cause blocks to show up that you may not expect, like oceans suddenly becoming their sandy floors instead of the water they're covered in. And while some of these problems can be mitigated by having a sufficiently fast loading system and tuning the quality settings just right, not every computer will be able to handle those settings, so trade-offs will have to be made. Are you willing to have a weird-looking skyscraper? In fact, how much do you, the person watching this video, care about any of this? While I anticipate the response to this question will be skewed since I'm posting this on a channel dedicated to extreme render distances in Minecraft, I'm still curious. Would you be excited if the next major Minecraft update included just a massive increase to the render distance? Or would you be more excited if Mojang added a new dimension or mob? When prioritizing tasks, Mojang has a balancing act to make. They have a limited number of people and a near unlimited number of things they can work on. So finding the most valuable use of each dev's time is important. Is a dev's time better spent adding a new breed of cow, or troubleshooting a rare crash that only happens to a small fraction of users? It all boils down to demand, and what you, the users, make the most noise about. Over the years, I've seen many people claim they'd love to have Mojang stop pushing updates for a year and just work on one big optimization update that doubles their performance. But take a step back for a minute and seriously ask yourself, how excited would you actually be if they did that? How much fan art would a doubling in FPS get? How many YouTube videos would there be praising this new and improved performance? How much public discussion would pop up where people are excitedly talking about how their game is smoother or they can finally run Minecraft on an old Pentium? Now, let's compare this to something that did get a lot of positive reception, the Happy Ghast. When the Happy Ghast first came out, there was fan art galore. People were excitedly talking about how it would revolutionize building. Now, I might be wrong, but I don't think suddenly having a render distance of 512 would bring the same level of hype that a new mob would, especially compared to the amount of time it would take to add. I don't know how long it took Mojang to add the Happy Ghast, but for some reason I have a feeling it was a lot less than the 4,000 hours it took to get Distant Horizons into beta. But maybe I'm wrong about all this. Maybe the average Minecrafter would find a massive increase to the game's render distance worth a lot of hype. If you feel LODs or extreme render distance are important and would significantly improve the game, make some noise. Upload a YouTube video, start a discussion on Reddit. If enough people all show interest in this feature, Mojang is more likely to consider it. But remember, don't spam anyone and don't message any of the Mojang devs directly. Spam is a great way to hurt your cause, and the devs aren't the ones you need to convince. Please, just be courteous, okay? Alright, we're almost at the end, but before I wrap this up, let's go over a few of the incorrect reasons for why Minecraft hasn't added LODs yet. Because, believe it or not every reason out there is valid. The first reason is Minecraft running on Java. A common misconception is that Java, the programming language Minecraft is built on, isn't fast enough or doesn't support LODs. And while it's true that Java isn't the fastest language on the market, it isn't slow either. To prove this point, I'd like to point out the many mods that already have LODs. Voxy, Big Globe, and Distant Horizons, who all run on Java. But what if we swapped to a different, faster language like C++? Would that magically solve all of our problems? While using a faster language would help some, it wouldn't be the silver bullet some people claim it would. To prove my point, let's look at how Minecraft runs when written in C++. Minecraft Bedrock Edition is able to render and generate terrain quite a bit faster than its Java sibling, but it doesn't have LODs and is still fairly limited in its render distance. Quick side note, I've seen a few people incorrectly claim that Bedrock has LODs, but unfortunately that isn't the case. While Bedrock does do a couple neat optimizations that Java doesn't, like changing kelp from a full model into a flat texture once it gets far away, or just not rendering certain blocks as they get further from the camera, none of these changes are LODs, since they don't affect the terrain geometry itself, and while they're all good optimizations, they don't solve the core issue discussed earlier in this video, like explosive chunk count. Simply moving to a faster language doesn't mean the limiting factors I've covered in this video would magically be solved. Trying to generate and render a million chunks will always be difficult regardless of the language being used. So if the language isn't the problem, since Minecraft rewritten in a faster language still can't handle extreme render distances, that means Minecraft itself isn't optimized enough, right? Not quite. Straight optimizations can only get you so far. Let's take a quick look at the two most popular optimization mods, Sodium and Optifine. Both optimize Minecraft's renderer, improving performance. However, neither of them are able to optimize the game so much that you can suddenly get triple-digit render distances. Optimization is important, don't get me wrong, but sometimes a change in approach is much more important than simply speeding up your existing approach. For example, if I was traveling from Los Angeles to New York, it doesn't matter if I'm driving a Honda Civic or a supercar, a passenger jet will always get me there faster. Lastly is an opinion I've seen posted a number of times online. Usually as a joke, but on the off chance anyone's actually taking it seriously, I wanted to cover. Mojang devs are lazy. And by extension, if they only worked harder, all of Minecraft's problems would be fixed and we could render all the way to the world border, and also have flying cows. Usually I see this sentiment under posts where mods are showcased doing amazing things that people would love to see added to the vanilla game, usually with a thought process that goes something like this. A random mod dev in their basement added a super cool feature to Minecraft. That means it's possible. Therefore, the only thing that's stopping Minecraft and Mojang from adding this is some sort of laziness. While it is true that mods are a great way to showcase a proof of concept, that doesn't automatically mean that exact mod could be quickly or even easily added to the base game. Let me remind you, Distant Horizons took around 2 years of full development time, and if Mojang wants to add something similar, it'd likely take just as long, if not longer, due to the increased level of quality they need to achieve. But even assuming a significant decrease in time cost, Mojang devs can't just add whatever they want. While I can't speak about the process Minecraft features need to go through before they can be added, I can speak as a software developer who has been both part of teams and who has led teams in the past. When adding a new feature, Mojang would have to 1. Discuss the feature with the design team and confirm it fits in the game. 2. Confirm it meshes well with the existing features from a user perspective. 3. Run the feature through quality assurance to check for direct bugs. 4. Run the whole game through quality assurance to check for new indirect bugs. 5. Validate that it confirms with the existing codebase. 6. Localize any text that the new feature has. 7. Repeat steps 3 through 5 in an entirely different language to keep parity between Bedrock and Java editions. Mojang devs aren't lazy. They just have to deal with a lot of moving parts that all need to be coordinated before they can move forward. Any random idiot can make a buggy mod for Minecraft. It takes a lot more work to add a polished feature to the vanilla game. Software development is tricky, with game development being even more so. Hopefully this video helped shed some light on how complicated a problem extreme render distances are to implement and why Mojang hasn't done it already. Thanks again to Cortex, Ishlind, Builderboy, and everyone else who helped with this script. And hey, maybe we'll get lucky. Maybe Mojang will add LODs right after I post this video, making everything I said a moot point and letting mods like Voxy, Farplane 2, and Distant Horizons retire.